Now the important essay of this chapter, first essay is Schrodinger's time dependent wave equation. So we have to study both time dependent and time independent wave equation. So the first one is Schrodinger's time dependent wave equation, which means it is an equation which depends on time. Okay, so for that we are starting from the wave function psi of xt. We are assuming a form for this wave function, that is psi of xt is equal to a e raised to I into kx minus omega t. This is the format of psi of xt. So many formats are available, but we are choosing this format, a e raised to I into kx minus omega t, where a is the amplitude and x is the position, omega means angular frequency, and t is the time. Now we have a constant here, k. This is known as propagation constant. So what is this propagation constant? It is defined as k is equal to phase change divided by path change. Phase change divided by path change is known as propagation constant k. So phase change is 2 pi and the path change is lambda. For that we have to consider a full wave. Suppose this is our wave, then the change in path will be lambda. Lambda will be the path length of this wave. So that is the change in path. So that path change is equal to lambda. And change in phase, which means change in angle, is 0 to 2 pi. So 0 pi, 2 pi, that's the change in angle. So that the phase change will be 2 pi, because while we are considering a single wave, the phase changes from 0 to 2 pi. So that we can write phase change is equal to 2 pi and path change is equal to lambda, or k is equal to 2 pi by lambda. Now we are going to substitute for this k and omega. So I have to make substitutions for k and omega. So this is a substitution for k and this one is for omega. First of all, what is the substitution for k? For that we are starting from the de Broglie wavelength, that is lambda is equal to h by p. This is our de Broglie wavelength, and I am multiplying this with 2 pi and dividing this with 2 pi. Okay, lambda by p, h by p into 2 pi by 2 pi. And this 2 pi and p can be interchanged, which is lambda is equal to h by 2 pi into 2 pi by p. Just interchanging this denominators, p to this side and 2 pi to this side. So that we have an h by 2 pi here, which means h cut. H cut is equal to h by 2 pi. So lambda is equal to h cut into remaining terms 2 pi by p. Clear? Now from here, what is 2 pi by lambda? 2 pi by lambda. Lambda can be taken to the RHS. So 2 pi by lambda is equal to p by h cross. Arrange this equation. P can be taken to LHS and h cut can be taken to the LHS. So that 2 pi by lambda is equal to p by h cross, right? So 2 pi by lambda is k, that is k is equal to 2 pi by lambda. So instead of k, we are going to substitute p by h cross. Similarly, we have to find a substitution for omega. For that, we are considering this equation, E is equal to h nu. From here, nu is equal to E by h and omega is equal to 2 pi nu. We have the basic equation, omega and frequency related with the equation. Omega is equal to 2 pi nu. That is 2 pi into, instead of nu, we can substitute this E by h. 2 pi into E by h. Okay, that is omega is equal to E into 2 pi by h. What is this 2 pi by h? H by 2 pi is h cut. Therefore, 2 pi by h is equal to reciprocal, 1 by h cross, right? So, omega is equal to E by h cross, because 2 pi by h cross is equal to 2 pi by h is equal to 1 by h cross. So, omega is equal to E by h cross or h cut. Okay, so we have the substitution for k is equal to p by h cross and omega is equal to E by h cross. Now this equation 1 can be written as, we are substituting these two equations in equation number 1, that is I of x is equal to, we have a here, e raised to I into, instead of k we have p by h cross, that is p by h cross, and remaining x minus omega, we have E by h cross and a remaining time t. Okay, so a e raised to I into p by h cross x minus E by h cross into t. Here we have a common factor h cross. So h cross can be taken outside. A e raised to I by h cross into remaining terms px minus et. So this is our first step of this derivation. We are choosing the format of solution and make substitution for k and omega. K is equal to p by h cross, omega is equal to e by h cross. Substituting these values in our equation number 1 so that the wave function can be changed to this one.